Please welcome your panel on Pushing the Boundaries of the Final Frontier, moderated by CEO of XPrize, Anousheh Ansari.
Good afternoon, everyone. Thank you for being here. Space has been something that has captured our imagination since early days of humanity. And we live in very exciting time because finally, I think we're at the point that we are truly pushing the boundaries. And we have an amazing panel tonight that will talk about how they have individually made a difference in the past and continue to push those boundaries forward. So instead of me introducing them, you have their bios in your apps. But I want to hear from each one of them in their own words how they have worked in this area in space and the final frontiers, and how their work is really expanding the horizon for us in the final frontiers of space. Let's start with you, Peter.
And do that in 2 minutes, right?
2 minutes.
Okay, that's easy. So I became passionate about space for two things. Apollo showed me what was possible, and Star Trek showed me where we were going. And when that didn't materialize fast enough, the question was, what could I do in my small way to help accelerate getting myself and everybody into space? I think everything we hold of value on Earth, metals, minerals, energy, real estate, is near infinite in quantities in space. And you know, millions of years from now, whatever we've evolved into, it's going to be these next few decades that the human race makes that transition to a multiplanetary species. So I've been an entrepreneur in space, starting half dozen companies, some nonprofits, XPrize, with this amazing woman, Anousheh Ansari, who's now our CEO, and companies like Zero G and Space Adventures and Planetary Resources and so forth. What's really different now is that it's a game that individuals and entrepreneurs can play in, which was never the case ever before. It always was dependent solely on governments. And because individuals can now take risks, because individuals can now actually capitalize and fund these efforts themselves, we're seeing an accelerating rate of change, of experimentation, of risk-taking. And I think it's the most exciting time ever to think about opening up the space frontier. And for me, I can't wait to go. Half this panel is gone. I think that's very unfair. But more than that, for me, the most important thing is how do we make space a sustainable, what I call an exothermic economic reaction? How do we make it possible for space to generate more revenue, more income, such that it's not dependent on any government budgets? It's something that is happening and growing and expanding. You saw some footage of Stephen Hawking flying. One of my great pleasures in life was having had a chance to fly Stephen Hawking into Zero G. And I remember when he was asked why, because it was very risky for him, it was because he thought the human race didn't have a future if we didn't become a multiplanetary species. That's a little pessimistic for me, but I do believe that it is we're at the beginning. This is the equivalent of the lungfish moving out of the oceans onto the land. And we're alive during the most exciting time ever in human history in terms of opening up space. So I'll leave it at that.
We'll come back with questions. Yeah. Dr. Bernard Harris.
Hello, everybody. I was one of those kids in 1969 looking at that little black and white television and being in awe as Neil and Buzz landed on the moon. And I declared on that day that I would become an astronaut. And lo and behold, a lot of work, and I finally got there. I joined the Astronaut Corps in 1990. I have been lucky enough to be on 2 space missions. The first one was called D2. It was a second mission with the German and European space agencies. We spent about 12 days on orbit and had about 91 different experiments that we did on board. I was a crew medical officer for that because I'm actually, part of my background is I actually went to medical school. So I was one of those guys that went to medical school and became a crew medical officer. My second mission was in '95 when I flew on the first shuttle to go to the Russian space station. And it was an incredible period of time. We were just getting together with the Russians. There was a lot of talk about the Russians now, and thank God that they have been our partners for a long time that allowed us to get to the International Space Station. And so I feel that I was part of that team that brought this whole thing together. That mission was 9 days, and I was lucky enough to do a spacewalk on that mission. It was incredible to not only blast off in space, which I hope we get a chance to talk about, but to walk outside and see my fellow crew members in the spaceship, and then below that, of course, the Earth, and behind that, the sea of stars called the Milky Way galaxy. So that's my background as an astronaut and as a crew medical officer. I guess I should also say on my second mission, I was the payload commander for that mission. And that person is responsible for making sure that all of the experiments get conducted on that mission. These days, I now run the National Math and Science Initiative. I've been a big advocate for making sure that our kids have the tools that's necessary for them to fulfill their dreams, no matter what their dreams are. And I think that STEM education is the heart of everything that we do. Even the space program.
Absolutely, absolutely. Thank you. Steve Isakowitz.
Thank you, Anousheh. Thanks for the invite, and appreciate being up here with the panel. I don't know if the team could put up the slide that I had, but I wanted to sort of give my perspective of why I am so excited about being part of the final frontier. And I would actually go back to for those that are in this room that might happen to be more than 62 years old, you lived in a time when there was nothing in space, right? So even though we're in the final frontier, we have all in this room been part of the beginning of the final frontier. This simulation I want to run through here, if you can go to the next one. What this shows is these little specks of objects show that over time, if you look at the bottom right corner, is the year from which we put all these different objects in space. Some of them satellites, some of them debris of rockets that didn't come back to Earth. As you can see, over time, we start seeing rings of satellites in geosynchronous orbit to allow us to communicate, to do our weather systems. You see the beehive of the greatest amount of activity is those satellites that are closest to Earth, which is where we have our astronauts and our space station and where our space shuttle allows to fly. The other ones that look like they're specked all over the place, that's the GPS satellites that give us navigation to tell us anywhere we go in the world. That's like pretty amazing. You know, we have since 1957, we've put over 40,000 objects in space. Some of them intentional and some of them debris that happens.
Wow.
As a result, there's three things that I think are most exciting about space today that I've spent my career on, and I'll just sort of summarize it as being competitive, congested, and contested. And what I mean by competitive, it's sort of like what Peter pointed out. This is the most exciting time in space. For the first time, it's not just nations, but entrepreneurs and companies that are putting up more satellites into space than we've ever flown into space before. Today, we have 20,000 objects that we track. We're looking to double that, possibly in the next 10 years, most of that being driven by commercial activity that's going on. And NASA knows that. NASA's talking about going back to the moon, but this time in partnership with industry. Congested for the simulation that we're just looking at. Space is actually getting a little bit crowded. It's not just the LA freeways that are being backed up these days. It's hard to believe, but we are putting up enough things in space that if we don't take care of the environment of space, things start to slam into each other, and it gets to a point where it won't be safe. So it is more important that we are responsible and we take care of what those things we put into space. Lastly, contested. Space gives us an incredible ability from a national security standpoint to be able to have a military that can go anywhere in the world with our drones, with our soldiers, with our bombers, to listen to terrorists from our satellites that see when bad things are happening, and the world knows it. Our adversaries are increasingly looking for ways to jam our satellites, to negate our satellites, and if need be, to destroy our satellites. And that's why you hear discussions on Space Force and other things. It's because space is being very much a contested environment. So my career has been in the private sector. I've been in startups, big aerospace companies. I've also been working for the government at NASA, and I've also been at a startup company, and now most recently I'm at an organization called Aerospace Corporation, which we cover all three of these areas, which is where I see the future going.
Thank you. Leland Melvin?
Thank you, Anousheh, and panelists. Thank you for being here. I, not like Bernard, in 1969, was not the kid that wanted to be an astronaut. I was holding the rabbit ears on the black and white television set, adjusting them so my parents and my sister could see Neil and Buzz walking on the moon. I wanted to be Arthur Ashe, who was the tennis player who trained 5 blocks down the street from me in Lynchburg, Virginia. So I wanted to be that guy. And through a series of events going through football and tennis and the NFL, I ended up working for NASA Langley Research Center. And a friend of mine said, Leland, you'd be a great astronaut. I just laughed at him. I'm like, yeah, me, an astronaut? And then this other friend of mine got in, Charlie Camarda. And I said, if NASA's letting knuckleheads get that in to be astronauts, I can be one too. So I applied the next selection and I got in. And when I went to space on my first mission in 2008, I'll never forget that I thought this aha moment would come when I installed the Columbus laboratory with the Canadian robotic arm. And after that installation, everyone in Europe was like celebrating, Leland, 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 because their job security was in place with that module. What happened next changed me forever. The first female commander, Dr. Peggy Whitson, she invited us over to the Russian segment to break bread to have this meal. She said, you guys bring the rehydrated vegetables. So we float over with a bag of vegetables. We get to the service module, and it's like a Benetton commercial. African-American, Asian-American, French, German, Russian, the first female commander, breaking bread at 17,500 miles per hour, going around the planet every 90 minutes, while listening to Sade's Smooth Operator. This was the moment, right? This like blew my mind. And that Columbus laboratory installation paled in comparison to looking out at the planet and seeing that I'm flying over Lynchburg, Virginia, my hometown. 7 minutes later, we're flying over Paris, and Leo Eilhart's is looking down where his parents are probably breaking bread with some wine and cheese, and Yuri's looking off to Russia, maybe his parents are having borscht. This was the moment I had a perspective shift cognitively that changed the way I looked at humanity. And I think the final frontier of space is to really look back at the planet and take the exploration that we do to help more people get this experience of this orbital shift. My colleague here, George, is trying to get people to space with Virgin, Elon, everyone's trying to get people to space. But when you think about the number of people that are going to actually take that ride and the number of people on the planet that need to get this shift so that we can come together, that's the frontier that I'm trying to help advance. And I'm working with Anousheh on a program called Constellation, trying to give people these experiences, as well as an organization called Base 11, where we have, and he was actually inspired by you, Peter, Landon Taylor, to have an equivalent XPrize to give students, college students, $1 million if they can get to the von Karman line with a liquid propelled rocket. And so that's something I'm working on now. But that final frontier is to bring everyone along in this experience as you're doing, as everyone in this panel is doing.
Thank you, Leland. George Whiteside?
Well, that is a fantastic act to follow. So my name is George Whiteside. I'm the CEO of Virgin Galactic, which is Richard Branson's space company. And I wanted to start off with a little statistic. So how many people do you think have been to space ever? Just call out a number. What do you think? 500, yes. It's a very well-educated crowd. I should know better. But Milken, it's probably Mike Milken back there. Anyway, so it's 571, I think. I may be off by 1 or 2. But I think that is a crazily small number, right? You know, so we fit that many people on board an Airbus 380, right? And that's the number of people who have been to space ever, 571 different individuals. And so at Galactic, we have more than that already signed up to fly. And I think what we're about to hit is this amazing inflection point in human history where space becomes open for everyone. We have lived through 50 years where space was sort of the province of governments, primarily, and we're moving into a time when space is the province of everyone. And that is not just on the human spaceflight side, it's also on the satellite side, where high schools are now building their own satellites. So people can fly on a secondary ride to space, and almost anyone now can get involved in space in a real way. I am personally very excited about the idea of flying hundreds and eventually thousands of people into space for the reason that Leland sort of put so eloquently, which is that I believe that the perspective of space will have a profound impact on our home planet. The idea that basically we are all on, the proverbial spaceship Earth, I think is fundamental to solving some of humanity's greatest challenges. And if we can share that perspective, first with some of our customers who go up to space, and then they bring that perspective that Leland said so well, and Anousheh, Bernard have also captured so well, I think that will be a profound thing for the planet. But, we are going to go through an amazing time, and at Virgin Galactic, we're dedicated to one piece of that, which is essentially democratizing space.
Thank you, George. So as you've seen, we have an incredible panel here. 570 people in space, 3 of them are sitting here on this panel, and people from really diverse backgrounds. So Peter, let me start with you. You co-founded Singularity University. You've written best-selling books, Abundance and Bold, about exponential technologies. How do you see the future of the future of exponential technologies changing future of space?
Listen, I got my friends on stage. I'm going to take a photo. So the question is, how is exponential technologies going to change commercial space? So I remember I started my first rocket company in 1989, and we were trying to repurpose black brants for creating a multi-staged orbital vehicle. And it was expensive and difficult, and everything in space was the province of just government large budget programs. And I mean, exponential technologies have created these, which have more computational power. At the end of the day, we're seeing 3D printed rocket engines, we're seeing AI enable the discovery of planets around distant stars. Everything is changing. And ultimately, it's the enablement of the small team. And so in a world, we're hitting a world right now where there's more capital than any time ever in human history, right? So in 2017, we had all-time highs in venture capital, crowdfunding, sovereign wealth investments, and then all-time highs again in 2018. And we'll probably hit all-time highs again in 2019. So more capital coming in means there's more availability for teams to take big, bold, crazy risk ideas. So, I mean, that's the, the basic premise of the XPrize as well, which I hope you'll ask me a question about, where small teams can do what was only possible by larger groups before. And I think we see the emergence of Virgin Galactic, of SpaceX, of Blue Origin, and this long tail. I mean, it's insane, right, that there are on the order of 6 venture-backed small launcher companies. That's crazy. That never existed before, right? And the fact that venture capital is willing to back these means that there's the potential for a true renaissance. We're not at the PC or the cell phone yet in space, but we're getting there. Ultimately, the challenge is going to be how do we create businesses in the space arena. I'll keep it short so you come back eventually.
Yeah. Well, I knew the times have changed when I got an invitation to go to a Goldman Sachs space investment conference. So I knew, okay, the space investment phase has changed. So Bernard, you're a doctor, and we heard Elon talk about settlement on Mars. We've been talking about a settlement on the moon. Talk about how that impacts humans, and how do you see our bodies perhaps changing, maybe being enhanced? We have abilities to do genomic enhancements. How do you see humanity changing as we are going to settle on other celestial bodies?
We are going to be changing a lot. And if I could get my first, actually it will be, I believe, slide number 4. If you can pull that up. I'm making a guess here. Let's see what comes up. Just sort of. And if I could see it up here. Okay, I wanted to start with this slide to remind us what we're talking about. This is a picture of planet Earth, that pale blue dot down there at the bottom, below the rings of Saturn. And we're about 900 million miles away. And so the things that we're talking about now is not only going to the moon and going on to Mars, but perhaps even one day leaving the solar system. And there are a lot of challenges related to humans in space. And so if we can go to the next slide, I think I've got it outlined here. So what I thought I would do is just sort of, for the audience, let you know that there are a lot of things that go on in the human body. And as I said, I was one responsible for taking care of the crew. Immediately when we get on orbit, we have sort of what we call acute effects and a fluid shift. As you're sitting here right now, about 1/5 of your blood volume is in your lower extremities, held down there by gravity. And as you get into microgravity, that shifts up toward your head, and your body, that extra fluid gets sensed by your body. And so physically, what we have as an astronaut is we get fullness of the face. If I could show you a before and after picture of crews on the ground and crews on orbit, you would notice that our faces are full, and those of us who have wrinkles, those wrinkles go away because of that. And all of that is normal up there, except for the body then sees it as a fluid overload, and over time, you will reduce your blood volume. Your heart will shrink in size. You will develop atrophy. You'll lose, we lose about 1% of bone per month, just to get into some of the long-term effects there. And there are changes in the immune system. And if you've kept up with current events, you know that the twin study has resulted in changes in the genetic system. So microgravity has a tremendous effect. And probably the latest thing to the right part of this slide that hasn't gotten a lot of press, but just been touched upon. And it's because we've been spending longer periods of time in the International Space Station, we've noticed that people are having visual effects, things called scotomas. And to explain that to the layman audience, when you go to the doctor and they have you cover one eye and they ask you if you see this finger moving, that finger, they're checking your visual fields. So we actually have about 30% of folks who go into orbit that actually have holes in their visual fields. And we think that's because of increased intracranial pressure from that fluid shift and also being in microgravity. But the bottom line is that we're still trying to figure that out. So I lay that as the groundwork. We haven't left low Earth orbit yet. Imagine what life would be like on Mars if we're there for not just for a short period of time, a month or two, but perhaps years. And if those things happen with that, with this short exposure, imagine what a longer exposure would. And I always like to joke with audiences, when I was a kid, we used to watch, these sci-fi movies, and these Martians would come and attack us. Guess who's going to be the Martians? The Martians are going to be us, seeding planets, and particularly Mars, because that's the only one that we can go to that we think so far. And the result of that is if we stay there, we're going to change and adapt to that environment. And as we do, we'll be creating an entirely different race, human race.
The Martian human race.
Yes.
Thank you, Bernard. Steve, you have the unique perspective from government. Where do you see government fitting into the picture? What's the role of government in the future of space? And do you see collaboration with the public sector?
Yeah. So just to start on a personal note, so as I was listening to my panelists talk, I remember as a kid when I used to see those early rockets take off and blow up, I used to try to figure out, I wonder if I could build my own rocket. Why do I have to be part of NASA or the government, or then it was only US and the Soviet Union. So I had discovered at the age of 8 that model rockets, no matter how many you tape together, don't get to orbit. So I decided I'm going to go to MIT. I went to my engineering school, and I remember taking an entrepreneurship course, and I said, I'm going to build a satellite. And I remember looking into it, and people said, son, if you can raise $200-300 million, you too can get a satellite. All right, so that didn't work out either. So let's bring it now to the present. So a few years ago, I had a chance to work with George for Richard Branson, and Richard Branson comes up and says, I want you to build a rocket that goes to orbit. Now, I'm more than 8 years old at this point, but the crazy thing is we could do it. things have fundamentally changed. It's both the knowledge, the design, the computers, advanced manufacturing, advanced materials, 3D manufacturing. Suddenly you could actually build things that it didn't have to be a superpower to do it anymore. Similarly with satellites, we used to build satellites that are the size of a school bus. And sometimes they have to be because they do some pretty amazing things in orbit. But in the last 10, 20 years, we have had the ability to shrink these things down to an amazing scale. Just by one example is satellites, one of the hardest things they have to do is point in the right direction. When you're in space, you're not tied to anything. So we would build these sort of 3-axis designs that would allow the satellite to point in the right direction. And they were typically about this big. Today we're actually building satellites that do the same thing at this size. And this is not only good enough to point, but it points with such accuracy that for the first time we're actually able to use laser communications, where you have these little CubeSats about the size from my elbow to my hand that can point a laser to the ground and do high data rates, not only with the ground, but with each other.
Wow.
So to your question, now suddenly entrepreneurs, new companies, the cost of entry has dropped. You can build rockets, you can build satellites, not for hundreds of millions, but for tens of millions, a million, even less. The government is no longer the monopoly on these technologies, on these designs. They're seeing all these companies flourish around them and realize that if the government's going to be able to take advantage and truly be at the cutting edge, we have no choice, but the government needs to partner with the private industry. So whether it's to take advantage of the things that they're building that we could take advantage of, whether it's actually doing joint designs with them, such as what's happening in the launch industry right now with Elon Musk and Jeff Bezos and others, or whether it's even going back to the moon. There are serious discussions about having public-private partnerships where industry is actually going to help design and build the very things that will go back to the moon. So public-private partnership is alive and well, and it's paramount for the government ultimately to succeed.
That's great. And do you see that collaboration actually a global collaboration, or is it within each country you see collaboration happening?
I think certainly it's being extended at a global level because, again, as the cost of entry has gone down, what used to be 2 countries that would get into space, now there's over 60 that have satellites in space. More and more countries want to be part of it. So as the government, particularly is led through NASA, talks about going back to the moon, the discussions of international collaboration, eventually going on to Mars, has grown even bigger, as well as some of the science activity.
Do you think we will ever collaborate with China? They have a massive budget for their space program.
Well, and, China is certainly leading the way in some of the things that they're trying to do. They're trying to demonstrate the ability to get to the moon. We'll have to wait and see if ultimately we work together on it. But they're trying to develop the kind of technologies that we had 50 years ago. We know we can't go alone. So I think whether it's China, we've done with Russians on the space station. We work with them every day, as you've experienced in your own.
Thank you. Leland, I know you are a big believer in how space can inspire young people, and we need more engineers as we want all these amazing technologies to change our futures. So how do you see the role of space and STEM education and how we can really tap into that power?
Thanks, Anousheh. I think the biggest part of us inspiring that next generation of explorers is to ensure that we inspire all of the next generation of explorers. We have so many kids that don't believe that they can be part of this because of their zip code. And there was a 2014 Scientific American article that came out that said the best solutions and the best actually financial solutions involve us having the most diverse teams at the table working together. And that can be cut across all boards of diversity, whether it's ethnic, racial, gender, all of these things. And I think that, as a kid, Bernard, you wanted to be an astronaut by watching that moon landing. I did not, because I didn't see someone like me. And I let that keep me from even exploring that possibility, even though I like math and science and all these things. And so many kids don't believe it because they're not even given access. Like I remember when I first started giving public talks to kids about space, and I went into a classroom and I asked the kids in the class, I said, one small step for a man, one giant leap for mankind. And I asked all the kids to raise their hands and who wanted to be an astronaut, and only the boys raised their hands. And I asked the girls, why didn't you raise your hands? They said, well, you said it for the manned space program, and I'm not a man. So the language that we use is so important to ensure that our kids have these opportunities to see themselves as these space explorers. And then also experiential learning, the stuff we're doing at Base 11, to have students building rockets that will get to the von Karman line. That's real world stuff. When you think about back during the Apollo era, the flight controllers were in their 20s, their mid-20s. So these were the kids, that were deciding on the systems that were going to be used and saved to help our astronauts come back from the moon. And I think we need to push some of these activities down further, even in middle school kids. You have this gyro that could go on a CubeSat, that a middle school kid could help design something to go in space and be empowered, become an entrepreneur, and help us with this diversity problem. So that's one way.
Thank you. George, you talked about how you have more people signed up to go to space that have ever flown to space. And I believe in the future we want to see more and more of humanity actually having this amazing experience we all had, the overview effect. How do you think humanity will change once this becomes maybe as easy as maybe a luxury cruise that people can go on and they have this incredible experience? How would that change humanity, you think?
Well, I think there's going to be a lot of different effects, and it'll, right now, other than like this crowd, maybe, most people don't know an astronaut, right? At least, I think that's probably true. But we're going to be living in a future where most people do know an astronaut. They know somebody who's been to space, and that person will be able to communicate their experience in going into space and also experience or get a sense of that experience that you described so well of leaving the planet and looking back at our home planet. And I think that, we as a planet, as a people who inhabit the planet, and we're sort of the crew of the planet right now, we need to, understand. I build spaceships for a living, right? That the Earth is the best spaceship that has ever been built, right? It's essentially autonomously supported life for 3+ billion years, which is like remarkable, right? It's got systems for, energy and food production and asteroid defense and energy, thermal radiation, energy. It's got all these autonomous systems, but we need to teach the next crew, which is essentially, the next generation, that we have gotten to the point as a species that we can sort of shift the parameters of this spaceship. And so that's not something that's comfortable for humanity to get. We haven't, for 200,000 years or whatever it is that's human Homo sapiens have been around, we haven't had the experience of been able to change the global spaceship parameters. But so I think what I guess I'm working my way around to is that I basically agree that we have to teach the next generation that they are in charge of this global spaceship. And I view space as sort of the crucial teaching tool in order to do that.
Thank you. Peter, I jumped ship to come to XPrize because I love XPrize and I believe in the power of competition. What excites you about potential competitions that can really get the crowd and the innovators around the globe involved in space?
So I'll answer that, but before, because I don't know, you didn't introduce yourself. Anousheh is an amazing woman, right? She's built 3-4 companies. Her third one she sold for $1.3 billion and funded our first XPrize called the Ansari XPrize for spaceflight. Then flew privately to the space station on a Soyuz, spent 11 days in space, and now we were able to rip her away from other companies. She's now kicked me up to chairman. She's CEO of the XPrize, so very proud to have this woman at our helm. Mm-hmm. Yeah. Our first XPrize was the Ansari XPrize. It was driven out of passion, out of the desire to want to go into space personally. When Burt Rutan built it, backed by Paul Allen, and Richard Branson came in after turning me down twice to fund it, but that was okay, because I met Anousheh. And then, of course, Virgin Galactic was born out of that. And that was a perfect 1-2 punch of setting out this audacious goal, having 26 teams around the world, spending $100 million to win Anousheh's $10 million prize. That was great. We ended up launching our next space prize was the Google Lunar X Prize. It was a $30 million prize put up by Google, lasted for 10 years. It ended, but we had, again, about 30 teams competing for that. And I was in Israel with Anousheh, with Mark last month, And we were there for the attempted landing of the Bereshit lunar lander by Space.io. And it was pretty incredible, right? This is we had about 30 teams register for that lunar XPrize. The Israeli team was the last team to register for it. But they thought they could win that prize for $8 million, by the way, of expenditure, just to be clear. It cost them $100 million of capital. We had amazing benefactor Morris Kahn, who funded most of that. If any of you are coming to Visioneering this year, which is going to be at Paramount Studios, October 4, 5, 6, we're going to have the Bereshit team and Morris Kahn talking about their experience of going to the moon. But they got very close, and they're going to make an attempt again in the next 2 years. So it's great that small teams, under 50 engineers, could actually build and launch a lunar lander. We're talking about what we do next in space-related XPrizes. We are looking at a wide range of things. Maybe it's asteroid detection and deflection. Another area I'm very interested in. How many folks here were affected by the California fires last year? Anybody raise their hand? So one of the things that we want to do, we're in the middle of it, I was just on the phone with Governor Newsom about this, is can we create a fire detection and extinction XPrize? Can you detect it from space or from drones, and then within 10 minutes put it out, right? So before it spreads. And by the way, if that's of interest to you, please see me. We're looking for seed capital to do the design of that prize. And I think it's a great XPrize, very measurable. But these are the kinds of secondary benefits we're going to see from space in the integration of near-term benefits besides the long-term benefits of keeping ourselves from being another extinction event.
Thank you. We have 5 more minutes before we open it up to the audience. So I wanted to just maybe open it up to the panel and see what is the most exciting thing happening in space right now? Any specific area you're particularly interested and you see the audience here, Milken Institute, and everyone here can actually help push that frontier with you.
Well, I'll jump in, Anousheh. I mean, my 2 cents is that the big revolution going on in space transportation is reusability. You know, the reason why space is so expensive is basically for 50 years, we've taken the equivalent of a 747 and flown it to, like, from New York to London, and then we throw away the 747 when we get there. That's why it costs $100 million to get to space. And the reason why it doesn't cost that to go to London is that, you know, you reuse that same 747 10,000 times. And so, you know, what we're trying to do at Galactic is bring airline-like reusability to space operations. And if we can do that, you basically amortize the entire cost of the hardware down to a trivial amount, and your costs become the costs of fuel and the people operating it. And that is crucial because then, you know, if you have that reduction in cost of 10 times, 100 times or more, then you can do a tremendously larger amount of activity in space. And we actually ultimately would love to take you know, space-like operations to airline-like destinations and bringing, you know, point-to-point travel from one part of the planet to another, you know, at high speed. We've been chugging through the atmosphere at Mach 0.8. I'm sure many people flew from different parts of the world, and they're used to flying on planes for 8 hours, 10 hours, even 15, 16 hours. It's crazy that 50 years later, you know, after the dawn of the jet age, we're still going Mach 0.8. The technology exists to change this, and we're working on that problem. But I think those are the kinds of things, that's one thing that's very exciting right now.
Great.
And I would add something else. I want you to think about this. Since the International Space Station and going forward, we will always be in space. There will never be a time that we will not have human beings in space. And so from my standpoint as a medical doctor, I see that this orbiting laboratory, it actually is a national lab right now, will provide us a tremendous opportunity to see how the body reacts. Now, I gave you a quick overview of all the things that happen to the human body, and that certainly will be a challenge to us, but with challenges comes innovation. And so if you think about, we've been, almost 70 years in the space program, and in humans maybe around 50 or 60 years, and we've learned a lot. We have, within NASA, every year we publish something called our spin-off catalog. And because of that experience in space, we have come up with a lot of innovations that are not only useful for astronauts who go into space like myself, but help folks here on Earth. And I can go through a whole litany, and I'll just let you to imagine that. the miniaturization of electronics, for example, the imaging technology that was developed in the space program. So I'm excited by the fact that we're going to have humans up there creating new ideas, new inventions, new innovations that are going to serve the folks on this planet and perhaps on other planets as we go to Mars and beyond.
I agree with that.
Okay, so one thing I would add to that is, since George mentioned, is Homo sapiens, we've been around, I don't know, a couple 100,000 years. Probably the most profound questions we've always asked is, what's our origin, what's our future, and are we alone in the universe? I think it's quite possible that in our lifetimes, we're going to have answers to all three of that. Next few years, we're going to be launching the Webb telescope. That's going to be a replacement for the Hubble Space Telescope. That'll literally be like a time machine that'll be able to look back in time to nearly the very beginnings of the Big Bang.
Yeah.
There you go.
That is
James Webb fan.
We've talked about our astronaut program. You know, we put footprints on the moon. We're going to be celebrating 50 years when Neil Armstrong stepped on the moon in July. But I think in the next few years, we're going to go back to the moon to stay, and we're going to go to Mars, and I think we'll see footprints in our lifetime on Mars. And then are we alone? I think for the first time in history, we actually have the capability to see planets around other stars. The kinds of telescopes we're talking about deploying in the next decade or two will be so exquisite that actually it's quite possible that we'll be able to see early detections of those planets and potentially indications of what might be indicators of life somewhere else. It'll maybe perhaps answer the question, are we alone?
Absolutely. I'm a big Hubble geek. I love the space imagery. Leland?
Oh, I think the most exciting thing that I've seen lately is to go into a place where, say, South Central, and a kid has a NASA t-shirt on. And it's something that you would have never seen before with all the movies that have come out, with all the things from, you know, science fiction to science fact, to think that that's a possibility for this kid who's, you know, in some disenfranchised way, thinks that they could possibly do this thing that these other people have done that haven't really been from their neighborhood. So that's exciting to me, is that next generation of explorers crossing all zip codes and all borders.
Thank you. So let's open it up to the audience and answer some questions. Would you stand up so they can bring the mic to you and introduce yourself, please?
Okay.
Thanks.
Hi, Max Gauckman, Head of Asset Allocation for Pacific Life. We've heard a lot during the conference about how we're harnessing artificial intelligence for what we're doing here on Earth. I'd love to hear how you're using AI to get us further out in space across your various projects.
So I can maybe say a few words. At XPrize, actually, we look at AI and how AI can be used in many different works. So we have launched an AI for good and also uses of AI and space technology. We've seen a lot of disaster detection from space using AI, prediction models for environmental changes, and detection of asteroids. And we also look at AI as just fundamentally looking at modeling and finding data about exoplanets and potential life out there.
Yes, I would just add to it is the satellites we launch, as amazing as they are, as I've just described, they're kind of dumb pieces of hardware. You know, they just sort of bounce off communications, they take a picture and send it back down. We're talking about building a next generation of satellites to really be brilliant satellites that allow them literally to think on their own. Not just to take pictures, but to actually identify things that are interesting and take pictures of that, process them on board, and decide what's the most interesting stuff. And if it finds that it's interesting, take another picture of it. Satellites that are smart enough to see other satellites around it and to be able to cooperate, and maybe fly satellites as swarms. So if one goes down, another one takes the place, you know, as you go forward. I think it allows the human operator to play a role where it's just supposed to be at the highest level of determination, but it's really these satellites. And we do worry about a future where satellites could be under cyber attack, where, again, they could be jammed, or lasers could be shot at them, as I mentioned earlier, in a contested space environment. We want to have satellites that will know this. You know, right now, today, if a satellite goes down, we always assume it's because of natural causes, cosmic ray, something broke on the satellite. It's quite possible that someone's poking the eyes out of our satellite, and we don't know it. So AI will enable the satellites to be brilliant enough to know when something bad is happening on board and be able to take action without having the human operator.
Yes.
Very good. Hi, my name's Jeff Dunn, and actually, I want to follow up on a question actually that I posed to Steve at lunch today, but it's actually for the whole panel. And the question has to do with the capability, the manufacturing capabilities, and the other technological capabilities that are possible in space that are not really possible or very difficult here on the Earth. In the next decade or so, for anyone on the panel, what do you see as some of the most realistic kinds of research and manufacturing that we can do in space that will help our lives here?
So some of the work I've seen, and probably you can speak to that a lot more, there is a lot of experience on board the space station in manufacturing, producing things in space, creation of different kinds of crystals, human organs or tissue samples that because of the unique microgravity of space, there's a lot more manufacturing possibility. But I'm also excited at uses of additive manufacturing, 3D printers that now are being used on international space stations.
Yeah, I think you covered it. On my first mission, we actually had a few commercial companies that were interested in manufacturing. So crystal growth was a big topic, not only for material processing, but also for drug manufacturing. So that worked really well. Interesting experiment we took up. We created new alloys on this particular mission for turbine blades, which are used, of course, in aircraft. And we were able to come up with much lighter and stronger material in space. And you can go to the NASA website and see it's SDS-55, and that actually will give you some of those results. And why? Because in zero gravity, we get rid of convection and buoyancy, all of those things that interfere with material processing here. If you think about mixing two different materials with two different densities, if you do that here on Earth, gravity will pull on the heavier material, and it will pull apart and cause microfractures in the material. Whereas you do that same thing in space, and essentially we took up about, I think, 3 or so furnaces in which we did this material processing. Because of that, it allowed us to come up with lighter, stronger material that's able to bind without having any fractures in it, as an example.
Yes.
Oh.
Hi, Jason Larian, Oncoming Developers. So you guys, there's a lot of conversation, and you see a lot of the headlines about talking about how we're going to get into space with using reusability, but to get to Mars, to get to a sustainable life on another planet, there's a lot of different technologies that haven't been really developed yet. And as an investor, I want to see stuff like deep space propulsion, things like that. What are the innovations that are going on now in private companies that we should take a look at and keep an eye on?
You're going to see the communications business since 1960-ish has been the economic driver for most of all space. Human has been a net, cash negative business, and communications has driven much of this in defense. We're about to see the explosion of a multitude of orbital systems, right? We have Starlink from SpaceX, we've got OneWeb from Greg Weiler, we've got Jeff Bezos' program, what's it called now? Kuiper?
Kuiper.
Anyway, there's on the order of 20,000 slated or 30,000 slated satellites to double your orbital debris. But what it's going to drive ultimately is going to be laser communications in space, right? There needs to be the equivalent of MCI, Microwave Communications Inc., where there are microwave links to Mars, to the moon, and basically the interplanetary internet is going to come into existence so that you've got reliable, constant communications at any point. Right now, it's insane that the Deep Space Network, DSN, is one landline that we point at Pluto, that we point at Mars. I mean, that's crazy. But that will change. Ultimately, I spend a lot of time thinking around the notion that on asteroids are wealth of platinum group metals, right? And so we're going to learn how to extract those resources from space and make platinum as cheap as aluminum someday, who knows, or at least fuel sources, liquid oxygen and hydrogen from carbonaceous chondrites. So those sorts of things are important. But I think the most important thing is the ability to experiment with human society as we go beyond Earth and nation states on Earth to the stars.
Great.
And I may just add, one of our colleagues, Franklin Diaz, MIT grad, I think he has a record for the most time in most missions in space, 7 missions in space. And as his side gig is that he's a physicist developing a plasma engine. So you were talking about how do we get there? And this plasma engine runs off of hydrogen that gets ignited by microwaves. And the nice thing about it is once you light this plasma engine, it burns continuously as long as you feed it fuel. So now you can fire this engine up in orbit. It doesn't have enough lift or specific gravity to get off the Earth, but once you're in orbit and you get this thing moving, it goes some ungodly speed and can cut the time to Mars from a year to a year and a half to 3 months. And so he's making some great inroads. And so I think you're going to see a lot of this propulsion technology that's going to be developed to allow us to do
He's
this
looking
in
for
a plant.
investors.
And he's looking for investors.
Ronzo?
Yes.
Hi, my name is Gray Davis, and 20 years ago I was a brand new governor of California. I can't tell you how exciting this panel is. I remember in my early days I was working with Jerry Brown. We used to go to Camp Edwards and see the space shuttle land. What a fantastic experience that was. I just wanted to make 2 points. Somebody asked about getting everyone excited about being an astronaut, and I just want to tell you the power of having the Space Shuttle Endeavour at Exposition Park, which is about 30 minutes from here near USC. They used to have about 1.2 million kids come by every year. Now it's about 2.7 million. Wow. So that's another 1.5 million kids that are being there primarily to get in the space shuttle, to crawl around, and imagine flying it themselves. Secondly, I want to pick up on something Peter said about using space to solve problems in California. So I'm working with Governor Newsom as a volunteer and a number of academics in California to put in infrared microwave cameras to detect fires more quickly and put them out more quickly. And we are working with Caltech and JPL. Our scientists have joined us, and they've joined the advisory committee, which I chair. I just want to tell you this technology is so fantastic that in the parts of the state where the cameras are up to date, roughly 200, mostly Orange County and San Diego, no deaths. The worst fire is 5,000 acres. And collectively in the state, we've identified 5 arsonists, caught them in the act. So we have great hope that in the next 2 years, we can get these cameras out throughout the state. And this is a problem that will be soluble. Instead of $12 billion worth of damage, you're probably looking at maybe 20% of that, which is much more manageable. So my question is, whether it's Peter or anyone else on the panel, are there other examples of how you think space can not only fire our imagination about what's possible in space, but solve problems here on Earth?
I've said a lot. You guys jump
Well, I mean, I think the great example people often point to is GPS. In fact, I'm always amazed that kids know the acronym GPS. They don't know what it stands for, but they know it's a GPS. GPS has really unleashed a whole economy of capabilities, whether it's knowing where you are, your iPhone, the whole banking system, the ability to do anything from anywhere because of a series of satellites that are out there. What I find exciting is sometimes we put these capabilities out into space. Like the first time we put GPS out there, it was for military purposes. We did not intend it for what it became, but it's one of those things that same thing with communications, that as many times we put these applications out in space and we have a very narrow view of what it could be used for, it's the applications and the entrepreneurs that come up with new ways of applying it in a way that really, drives our economy. Some people have sort of half joked that says we should have a day called the Day Without Space, where we should just turn everything off. And just give people a greater appreciation of how much our economy, how much of your well-being actually is a result of the kinds of things that we do in the space. Now, it's a terrible idea. We shouldn't have a day without space, but it drives home the point, to your point, that there is so much that we depend on for space that we often don't realize it.
I think from a social standpoint, when you look at, like on my first mission, we had African American, Asian American, French, German, Russian, the first female commander. If we could try to show people how we are getting along, and we've been working with the Russians for so many years, if we could get more people involved in this this endeavor to show what we can do in space, that why can't we replicate that back here on planet Earth? And break away these silos and these isms and have people coming together as one civilization.
We
I have a
have
question.
last question here.
Hi.
Oh, okay,
So-
we have some.
What do we do about the degradation of the human body when we're in space? And what kind of technologies are being implemented and are invested in, or can we look forward to in regards to bringing and helping with our degradation of our bodies now with the polluted environment that we're experiencing?
So I think you can answer, but before the answer, I'm just curious to know out of the audience, how many of you would you be willing to do genetic engineering of your body if you were chosen to go to space and live in space?
By the way,
Great, that's amazing.
Harvard professor George
I don't
Church.
know.
I mean, George Church is working on that, right? How do we increase your ability to do DNA rapid repair?
Yeah, yeah.
With Bernard.
Yeah, I was the only one that didn't raise my hand. I don't know about that just yet, but I can tell you what we're doing right now. So at the International Space Station, before I became an astronaut, I was involved in developing and running an area called the exercise countermeasure, or it was in general countermeasure facility. And in there, what we tried to do is to come up with ways in which to prevent all the things that I talked about, the muscle loss, the bone loss. And the best way to do that is exercise. So on board the International Space Station, we have 3 modalities of providing exercise. We have an ergometer that has no seat. It has a strap in which you wear a harness and you strap yourself to the pedals and you pedal kind of freely. We have a treadmill, again, harness attached through bungee cords to the treadmill, and you can run on the treadmill. Sort of funny side story. You only have a few minutes, so I won't tell the side story. But anyway, one of our astronauts who didn't have a lot of hair like me decided to run a marathon, and he ran a around-the-world marathon, in a sense. And as I think you heard from Leland, it only takes 90 minutes to go complete around the world. But he had a bald head, and so by the time he was done, he had a thin, clear afro of water that had come on his head, and he was moving back and forth. Anyway, the last modality that we have some funny pictures, is something that simulates lifting weights, and basically is used either bungee cords or springs or motors that simulate different weights. And then we're working with some pharmaceutical initiatives to freeze the bone at the same level that it is here on Earth. And that has applications for people, of course, who have osteoporosis here on Earth.
Well, I want to thank everyone for coming here, and I want to thank all of our amazing panelists.
Thank you.
I think this was great. Thank you.
Thanks, Anousheh.